Okay, so let's look at practice quiz 3, number 3. It says, consider two tanks labeled A and B. Tank A contains 100 gallons of solution in which is dissolved 20 pounds of salt. Tank B contains 200 gallons of solution in which is dissolved 40 pounds of salt. Pure water flows into tank A at a rate of 5 gallons a minute, and a drain at the bottom of the tank allows the solution to leave at a rate of 5 gallons per minute and flow directly into tank B. A drain at the bottom of tank B allows the solution to leave the tank at a rate of 2.5 gallons per minute. So find the salt content in tank B when the tank contains 250 gallons of solution. Okay, let me draw some pictures and make some definitions. So we're first going to define x of t to be the salt content in tank A at time t. And we're given here at time 0 there is 20 pounds of salt in tank A. So we know that x of 0 is 20. Let me write that here. So we have x of 0 is 20. And I'm going to define y of t to be the salt content in tank B at time t. So let me write that here. Okay, so y of t is salt content in tank B at time t. If you look up here, it says tank B contains 200 gallons of solution, which is dissolved 40 pounds of salt. So it means at time 0, so y of 0 would be 40. Okay, so we have these things. Now let me draw a picture. So let me do that. Okay, so drawing the picture over here, we have two tanks A and B. So you have 5 gallons of pure water coming in per minute into tank A. And tank A initially has 100 gallons in which is dissolved 20 pounds of salt. Okay, and then there's a drain at the bottom of tank A, and it's leaving at 5 gallons a minute also. So there's 5 gallons per minute coming in and 5 gallons a minute leaving tank A. So it looks like the volume of A is staying the same. Then it's flowing into tank B at a rate of 5 gallons a minute. And then there's a drain at the bottom of tank B, and it's leaving at 2.5 gallons a minute. So tank B initially has 200 gallons. So up here, tank B contains 200 gallons of solution. So B of 0 is 200. But you can see its volume is changing over time. So pretty much there's 5 gallons coming in, 2.5 leaving. So it looks like on net it's gaining 2.5 gallons. So I can write an equation here for B of t. Okay, so B of t, that's the volume in tank B, volume of solution, will be 200 plus 2.5 t, where t here is measured in minutes. Because in net there's 2.5 gallons coming in to tank B every minute, because there's 5 coming in, 2.5 leaving, so it's increasing by 2.5 gallons a minute. So this would be the equation for the volume of tank B. In tank A, well, there's 5 coming in, 5 leaving. So it looks like A of t is just going to be 100 here. So A of t is 100. Okay, so A of t is 100. So if we look here, we have to find the salt content in tank B when the tank contains 250 gallons of solution. So we have to set B of t equal to 250 and solve for t. And then that t value that we find, we'll have to then find y of that. Okay, so I'm out of space here, so let me erase a few things and we'll keep going. Okay, so summarizing, we have our x of t, salt content in tank A at time t, y of t, salt content in tank B at time t. We have x of 0 is 20, y of 0 is 40. We have the volume of A solution in tank A is 100, and the volume of solution in tank B is 200 plus 2.5 T. So we need to find y of t when b of t equals 250. So here's my picture over here. You got 5 gallons of pure water coming in per minute into tank A, 5 gallons per minute leaving at the bottom of A going into B, and 2.5 gallons leaving B. So, and we have also at time 0, A is 100 gallons and B is 200. Okay, so let's find, let's solve this. So I'll put 250 in place of B of t up here, and we'll solve this. So doing that, we get then, okay, so putting 200 plus 2.5 t here, subtracting 200 on both sides, we'll have then 2.5 t equals 50, then divided by 2.5, we get then, so then t is 20. So we need to find then y of 20. So let me write that here. We need to find y of 20. So we need to find y of 20. But in order to find y of 20, actually we're going to have to find x first. So let's write a differential equation involving x. So let's see how the salt content is changing in tank A. So it'll be dx dt. So dx dt will equal salt in minus salt out. Let me write it here. Okay, so dx dt, so it's a change in salt in tank A, will be salt in minus salt out. Well, there's 5 gallons a minute coming in, but that's pure water. So that would be 0 coming in. And then salt out, well, there's 5 gallons a minute leaving. That will not be pure water. So let me write the equation here and I'll explain. So I claim it will be 5 times x of t over 100. Well, the x of t would be the salt content in tank A at time t. If you divide it by 100, because there's 100 gallons in A, that would give you the salt per gallon. So this gives you the salt per gallon, this guy here. And I'm multiplying it by 5 because there's 5 gallons leaving per minute. So the salt per gallon times 5. So this would be the amount of salt leaving the tank. Okay? So again, the x of t over 100 would be the salt per gallon. And we're multiplying it by 5 because there's 5 gallons leaving. Okay, now this is a separable differential equation. We can solve it then. So I've separated the variables here because the 5 goes into 120, so this will be negative 1 over 20 here. I'm just writing, over here I'm just writing the x of t is just x. So divided both sides by x and multiplied both sides by dt, and I separate the variables like this. Now let's integrate both sides. Okay, so integrated both sides, we have 1 over x integral, so it'd be ln for this guy, and the negative 1 over 20 I pulled out in front, so integrating dt would be t, plus some constants. Let me write the answer here. So we'll have ln of x equals negative t over 20 plus c. Now let's exponentiate both sides of base e. So doing that, we get then e to the ln of x equals e to the minus t over 20 times e to the c. I'm going to call e to the c k, and then this will become just x of t on this side. So let me write it over here. So we'll have then x of t equals k e to the minus t over 20. Now we're going to use our condition up here that x is 0 is 20. So let's use that here to find our k value. Okay, so we're using x of 0 being 20, so we're going to put 20 in place of x of t here, and 0 in place of t. We'll have e to the 0 here. Looks like k is 20 then. So our answer for x of t will be x of t equals 20 e to the minus t over 20. Okay, so we have our x of t here. The bottom x of t equals 20 e to the minus t over 20. Okay, so I'm out of space, so let me erase a few things and we'll keep going. Okay, so summarizing what we got to here. So we have our b of t, and we have our x, and we're looking for a y of 20. So dy dt, so how the salt content is changing in tank B would be salt in minus salt out. So salt in, so coming into tank B we got 5 gallons from tank A, and then we have 2.5 leaving. So let's look at salt in. So it's 5 gallons from tank A. So let me write the answer. So the salt coming in would be, well, again, the x of t divided by 100 is salt per gallon, multiplying it by 5 because there's 5 gallons. So this is salt coming in, which is the same as the salt going out of A. Okay, and the salt leaving B would be 2.5. So we have to y of t divided by the volume times 2.5. So let me write it here. So it'd be 2.5 times the salt per gallon coming out of B. Well, y of t is the salt content in B. Then it's divided by the volume of the solution. So the volume of the solution would be the b of t. So it'd be 200 plus 2.5 t. This is the salt per gallon here multiplied by 2.5. Okay, so let's keep going. Okay, so in place of x of t now, I'm going to write 200 e to the minus t over 20, and 5 goes into 120, so it'll be 1 over 20 times this. The 20s will cancel there. And this guy here on the bottom, I can pull a 2.5 out. So 2.5 times 80, you can check, is 200. 2.5 times t is 2.5 t. 2.5 will cancel here. So let me simplify it a bit further here. So simplifying it further, we get to here. Okay, and we need to recognize now that this is a linear differential equation. Let's write it in the form so we can apply theorem 1 to it. So let's take this guy over here. So doing that, we get then. So we get this then dy dt plus, I'm writing as 1 over t plus 80 times y equals e to the minus t over 20. So this would be your p of t. This would be my f of t. So I can apply theorem 1 to this now. So applying theorem 1, we get. So applying theorem 1, then we'll have our u of t equals e to the integral of pt dt. Our p here is 1 over t plus 80. So it'll be e to the integral of 1 over t plus 80 dt. And this, you could use the u substitution, but it's just going to become natural log of t plus 80. It'll cancel here. So it just becomes t plus 80 here. Okay, now let's apply the next part of theorem 1. Okay, so using then u of t times y prime equals u of t times f of t. So our u here we just found was t plus 80 times our y prime equals our u t plus 80 times our f. Our f here is e to the minus t over 20. Now let's integrate both sides. So integrate both sides, we have this. So on the left side here, since you're taking the integral of a derivative, it's just going to be t plus 80 times y. And over here, we're going to have to use actually integration of parts on this. So I'm out of space here, so let me erase a few things and we'll keep going. Okay, so we got to here, so we have t plus 80 times y equals integral of t plus 80 e to the minus t over 20 dt. We're going to have to use integration of parts here. Let me write the integration of parts formula here. So here's my integration of parts formula. I'm going to let my u equal the t plus 80, and my dv then will be this over here. Let's make those substitutions. So letting u equal t plus 80, then du dt will be 1, so du equals dt, and my dv equals this stuff then. So my dv is e to the minus t over 20 dt. So integrating both sides, my v will be integral of e to the minus t over t dt. You could use a substitution on this and let you say w equal negative t over 20. I'll let you check that this should be your answer. You can check by taking derivative here, but it should be the integral. So it'll be negative 20 e to the minus t over 20. So let's make the substitutions up here then. So we have my u, I have my v, and I have my du. So let's make the substitutions up here. Doing that, we get then. So we'll get u times v. So it'll be u times v. So I'm putting the minus 20 in front here. Then it'll be integral of v. Sorry, minus integral of v. So it'll be minus 20 here, but there's not a minus sign here. So it'll be plus 20. I pulled out of the integral. So it'll be e to the minus t over 20 times dt, because du equals dt. Okay, and this integral right here, we've integrated right here. So making that substitution in, we get, so making a substitution here, you'd have negative 20 times 20 be negative 400, e to the minus t over 20. So here will be my final answer, plus c at the end here. Okay, so let's keep going. Okay, so next going to factor out, these first two terms here have an e and a negative 20 in common. So let's factor out negative 20 and e term out. So doing that, we get then. Okay, so I factored the minus 20 out on this side, and I factored the e out on this side. So I got this then, that's going to be then t plus 100 inside there. So let me write it here. So I get this then. Now let's solve for y, so let's divide both sides by t plus 80. So doing that, we get then, so solving for y of t, we get this then. Now we're going to use our initial condition. So I erased it, but y of 0, if you look back, we had equal 40. So let's use that here to find the c value. Okay, so we're going to use y of 0 equal 40. So I'm going to put 40 in place of y of t here, 0 in place of t here, 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 and here. So I'm out of space, so let me erase it, then we'll keep going. Okay, so we're putting 40 in place of y over here, 0 in place of t up here. So we get this. E to the 0 is 1. So solving for c, we get then, okay, so multiply both sides by 80, got this, then add 2,000 to both sides, you'll get c is 5,200. Okay, so let's replace that right here now. Okay, so there's our y of t, putting 5,200 for c. So lastly, what we're trying to find was y of 20. That was our ultimate goal. That'll be the salt content in tank B when tank B has 250 gallons. So y of 20 will be your answer we're looking for. So we're going to put 20 in place of t here, here, and here. So doing that, we get then. So putting 20 in place of t here, 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 and here. So putting 20 here is to be minus 1. So it'll be e to the minus 1. And then putting 20 in the other places for t. And simplifying, you can check it's minus 24 e to the minus 1 plus 52, which is roughly equal to 43.17. So that's going to be pounds of salt then. So that'll be your answer. Okay, so we're done with the question, so let's leave it there.